4.9, I'm trying to find my work from it too. So it was f prime of t equals 16 divided by the quantity of 1 plus t squared. And f of 1 equals 0. And then find f of x, I believe.
Find f of t.
Oh, yeah, sorry.
That's it?
It is.
Okay, perfect. So remember what I want my students to remember from any class I teach. Simplify, a factor. And maybe I should add here, we talked about this, but I would like to add, but I don't know how to add it. What to say it, how to put it in writing. When you look at this, I would like you to see this. It's extremely important. Because if you see this, so I don't know how to explain this. Alternate, don't say reality, please. What should I say? Alternate vision, or how should I put this in?
Like,
how should I?
Equivalent form?
Equivalent form, excellent.
Is probably how I would explain it.
Excellent.
Maybe even expanded form. I don't know that expanded is quite right.
Nope. Yep, that's equivalent form. That's the best. Thank you. So why? So for example, if I have 3x over 2, I do see 3/2 x. When I see 16 over, because when I find f of t, 16 is outside, and I know that arc tangent t is this. Arc tangent prime is this, plus a constant c. But if I don't see this when I look at this piece, I may have difficulties in understanding where this is coming from. Maybe, I'm not saying for sure, but always try to decompose what you're looking at. You either simplify, or you factor, or you think of equivalent forms.
So I did try to do that, but I didn't see it as arc tangent.
Because arc tangent prime, once you decompose it like this, or think of the equivalent form, arc tangent prime is 1 over 1 plus t squared, and you're done. Now, in order to find...
recognize that, so I had it as like 16 times, and then I had it as like negative exponents, and that's why I think I was struggling.
No, so, you cannot. When the denominator has 2 terms, don't even try. You can try only if the denominator has 1 term, not 2.
Yeah, it didn't work.
So now, in order to find c, all you have to say, well, when t is 1, the answer is 0. So 0 equals, so 16, arc tangent 1. Which angle has tangent 1?
That would be pi over 4.
Exactly. Exactly.
So then 4 pi?
Yes. So when I move 4 pi to the other side, c equals negative 4 pi. So then the function will then be f of t equals 16 arc tangent t minus 4 pi, and this is done. So please do not ever try to do anything to the denominator if it has 2 terms or more. It will be a waste of time. Now, not to confuse this with this. For example, if you have the cube root of t, yes, of course, I would write t to negative 1/3. But if I have 1 over the cube root of t plus 1, I'm stuck. Because it has 2 terms or 2 quantities, because this is not a polynomial. So don't try anything with two terms in a denominator. Okay, good. Anything else? You need help with anything else from Weber sign? Anything? Does it make sense now? So moving forward, I will always say something like this: simplify, factor, or simply look at equivalent form. Why? Why are these two equivalent? Because it's 16 over 1. 16 times 1 is 16. 1 times this is this. Okay. What would you like me to continue with?
Oh, actually, I have a question on 5.2 Weber sign.
I'm ready. Excellent.
It's number 4. It says use the midpoint rule.
Yes.
With given value of n to approximate the integral.
Yes.
So the integral is 0 to 40 of sine of square root of x dx, and then the n is equal to 4.
Okay. Awesome. So let's do that. So we always start with the interval. The interval is between 0 and 40. X is between 0 and 40. They're telling us 4 subintervals. Easy, nice. 10, 20, 30. If they want the midpoint rule, it means they want the midpoint. They don't want us to have the height at the leftmost point or the rightmost point. But imagine the function is somewhere here. I don't care about the function, but this is the height. This is the height. This is the height. And this is the height. I don't care how the function looks like. So when I approximate this with M4, then I have base times height, f of 5, plus base, it's out, times height, f of 15, plus base, which is a 10, times f of 25, plus base, which is outside already, 35. So let me show you how I would do this. I'll share my screen, and I will do it, and I will record it. So Amanda, if you want to turn off, because I'm not allowed to record anyone, and I don't want to record anyone, but I want to record this and post it. Maybe someone will look at it. Record on this computer. Yes, I want to record on this computer. Okay, so I would go to lists. I will edit a list. I will go up to list L1, clear, enter. I will go up to list L2, clear, enter. I will go back to list L1. X is 5, 15, 25, 35. Then I go and highlight list L2. Here's what I want in list L2. I want 10. I use a parenthesis or I don't, it doesn't matter in this case. And I want sine the square root of list L1, second one, go outside of the square root and close. So I want the calculator to take 5, put 5 in here, apply sine, multiply by 10 and give me the answer here. So I'm going to click enter. It will populate everything at once. Before I do anything else, I need to check one thing to make sure that the mode, since it's sine, a trig function, the mode must be in radian mode. I should have checked that first, but that's okay. Good, radian mode, fine. Then I second and quit, and I go to stats, and now I want to calculate something. I will use one variable stats. And I want list L2. I want to see the sum of the numbers in list L2. And I press enter. And I look for the symbol that we already know so well. This is my symbol. I don't care for this. I don't care for this. I don't care for anything else. I only care about the sum. What does this sum mean, or what does it do? Well, it adds all the numbers that you saw, those 4 numbers that existed in list L2. So this is how many decimal digits, Aaron?
Just it says 4.
Okay, so I have 98995 because, so let me stop here. Where is pause? Stop recording. Okay, that's all I needed. So because they said 4, here's the trick. This is 5. So this has to be increased to 0. And then this one increased to 0. And then this one to 9. So it will be -1199. Let me know if it works.
It did work. Thank you.
So that is the best thing to do. I don't want to calculate this and write millions of decimal digits. I don't want to calculate this. I don't want to calculate. No. So I go to the steps, and I will post that video. I go to the steps and do this. This times this. And the calculator does it instantaneously with this times this, with this times this, and this times this. And then I want to add them up. I'm not going to do it by hand. I'm going to use the stats and calculations. And I'm going to use one variable stats. And I only need the sum of x. But make sure that you're using list L2 or any list, but you have to enter that list that you want the sum for. Because if you by mistake do this for list L1, you're going to get the sum of x values. 5 plus 15 plus 25 plus 35. Who cares about that? So you have to make sure that you have list L2 where you have this times this, this times this, this times this, and this times this. Good. Excellent question. Anything else? Is there anything else you need help with? Web assigned or not? Anything? Anyone?
I have one.
I'm ready.
but I think it's going to be easier for you to pull it up.
Oh. Okay, so which problem am I looking at?
It's question 10 on, or I can share my screen if that works too. It's just not something I think me reading is going to be.
Okay, you have permission to. So it's question 10 in which section?
5.2.
Question 10. Okay, so they're giving us the rule. Okay, we know that's one of the properties. Yes, they're showing us the property again. Yes, that's fine. Use this property to estimate the value of the integral. So we have the integral from pi over 16 to pi over 12. And that is from 7 tangent 4x dx. So they want us to I see. So m is the absolute minimum and uppercase M is the absolute maximum of f on the given interval. Then, okay. So then for this function, we have to determine an absolute max and an absolute min on this interval in order to determine the smaller value. Use this property to estimate the value of the integral. So we have m b minus a they want us to calculate, and m b minus a. So that will be the upper and that will be the lower. Okay, so you can stop sharing, that's fine. So the interval for x is between pi over 16 and pi over 12. Thank you for asking that question, because I don't remember seeing this? Anyone? No one ever
No.
asked about
I
it.
didn't even know how to tackle it.
No. Nobody ever asked about it. So pi over 16 and pi over 12. So this is an increasing situation, right? Obviously, this is less than or equal to this, which is less than or equal to this. Now tangent, or 7 tangent 4x, is also an increasing function on this interval. And we can also graph it. Let's do that just to convince you. So I'm going to do this. I'm going to share my screen. I go to y equals, because it's very important to see, because if it's increasing, then I can keep. So what I'm trying to explain here is if the function, which is, I mean, we don't need to do anything because we know that tangent looks like this, right? Between vertical asymptotes, right? So this is an increasing interval. Tangent is an increasing function. I can apply 7 tangent 4x to this, 7 tangent 4x to this, and 7 tangent 4x to this. Why am I doing this? Because I need to determine the lowercase m, and I need to determine the uppercase m. That's why I need to do that. So I apply here 7 tangent 4 times pi over 16 will be less than or equal to 7 tangent 4x, which will be less than or equal to 7 tangent 4 times pi over 12. So that's the first step, because we want to find the lowercase m and the uppercase m. That's why we're doing this. Okay, I'll simplify, and I get 4. So I know the tangent pi over 4, you told me a few minutes ago, it's 1. So this piece is 7, which means this piece is 7. Less than or equal to 7 tangent 4x. So here I have pi over 3. And less than or equal to 7 times. I tell my students there is no need to remember tangent pi over 3. All you need to remember is that it's sine pi over 3 over cosine pi over 3. Sine pi over 3 is the square root of 3 over 2. Cosine pi over 3 is 1/2. So this piece is the square root of 3. So 7 less than or equal to 7 tangent 4x less than or equal to 7 the square root of 3. So this is the lowercase m, and this is the uppercase m. Lower bound, upper bound. Now, we know this property, m, small case m, b minus a, less than or equal to the integral from pi over 16 to pi over 12 from 7 tangent 4x dx less than or equal to m b minus a. Now this is 7. This is pi over 12 minus pi over 16. Pi over 12 minus pi over 16. This is 7 the square root of 3. And b minus a is the same, pi over 12 minus pi over 16. So now all we need to know, in order to enter the smallest, we have to calculate this, and we have to calculate this. I need to perform this operation and perform this operation. This will be the lowest, this will be the largest for the integral. So the integral will be between this number and this number. When I finish calculating them, I have to calculate these two. Okay, so let's do that. So how much is pi over 12 minus pi over 16? So pi over 12 minus pi over 16. So this is 2 squared times 3, and this is 2 to the 4th. So I need 2 to the 4th times 3. So this is 64. Okay. 48. What am I doing?
I think you're trying to.
I have to find the least common denominator.
Yeah, least common. Pretty sure it could be 16 if you do 4 over 3 times 12.
No,
Yeah, I was
16.
gonna say, or couldn't you like break it down to like 4? I know typically you don't do like factors.
The
but
least
there-
common denominator is the number that is divisible by both.
Right.
48
Yeah.
divided by 12 is 4, and 48 divided by 16 is 3. So 4 pi minus 3 pi is pi over 48. So the smaller area, the smaller piece is 7 pi over 48, less than or equal to the integral pi over 16 to pi over 12, 7 tangent 4x dx, less than or equal to 7 the square root of 3 pi over 48. So this, it has to be entered as the smallest, and this has to be entered as the largest. So let's enter 7 pi over 48 where it says the smallest. And for the largest, the same thing, but 7 the square root of 3 pi over 48.